Guys, welcome back to Spank Ranch Garage. Contaminated hydraulic oil, meaning hydraulic oil that has water in it, is becoming a real problem here at the Spank Ranch. So I have two machines here and then one down at my cabin that all have some levels of water in the hydraulic oil. And I have flushed it several times and it gets better each time, but that is getting very expensive. So even the cheapest fluid right now is $50 or $55 for 5 gallons. An example like this 410 backhoe you're gonna see outside here, that thing might need like 40 gallons worth of flushing to actually get that cleaned up. So I wanna see if I can come up with a design to make a piece of equipment that's gonna do that for us and save us a lot of money and fluid in the future. So this project is going to start and be based around this old compressed gas tank. I think it was an oxygen tank. I don't even know. I got this thing for free. Someone was like, oh, can you use it? I was like, sure, I love these tanks. Give it to me. But then I went to get it filled, and they wouldn't even touch it because the bottom of it is so rusty. I don't even think it made it to a hydro cert. I think they just said no way. So it's scrap, essentially. But we've got other plans for this thing, and I think it's going to do the job pretty well. So one of the things I've seen online with some of the backyard guys is they will basically pour their old oil into a turkey fryer and then heat it up and boil the water out. And that's not a terrible idea, but I think it puts a lot of wear and tear on the oil. I don't think this cheap oil that I run is really rated to run above 200 degrees like this. So my thought is, if we introduce vacuum to the situation, we can lower the boiling point of the water. And if I get a decent vacuum on it, I can lower that boiling point of the water to like 100 degrees Fahrenheit. So that way we're not changing the oil, we're not screwing with the additive package. The oil will run at 100 degrees all day, but that vacuum will allow us to get that boiling point down to safely remove the water. Plus then there's no open flame. I could probably leave it unattended and let it run. I need this to be fairly autonomous because I'm going to be doing this a lot. That backhoe holds about 30 gallons, and I'd imagine I'd have to flush it 2 or 3 full times to get the water down to where I'm happy with it. So, wonder if that's normal pipe thread. I hope so. Well guys, I realized while editing this video that maybe I wasn't clear about the need or why this problem exists. So, with normal engine oil, water separates out of it pretty good. So like if you have a car, if you've ever had a car with a bad head gasket where it's gotten coolant in the oil, if you let that thing sit overnight, pull the drain plug, the water comes out first, then the oil. Usually the oil is pretty clear by then. What I'm learning with this hydraulic fluid, just this cheapo VP stuff from Tractor Supply, but also the authentic John Deere, the J20C fluid, it seems to have emulsifiers in it to capture that water, encapsulate the water so it's not touching metal surfaces, I guess is the goal. They don't want large pockets of water settling into the bottom of the transmission or the bottom of a hydraulic tank, whatever. So that water, once it's in that fluid, is very hard to get out, and just gravity alone really doesn't separate it. I've done some testing where I've put watered down hydraulic oil in a bucket and not touched it for months. Pretty quickly, the first inch or so comes back to clean oil, and it gets worse as you go down the bucket, but it never fully separates, even after 6 months. Now, maybe after a couple years, it will separate. You could pump that clean oil off the top and be back in business. I don't have that kind of time. So it seems to be specific to hydraulic fluids. It's by design that they capture and carry water. I think John Deere fluid, I think I read it's good for 0.5% water, so 0.5% of whatever your volume is of water, it will safely carry without impacting the machine too far. I would assume we're well over 0.5%. We're probably like 5% if I had to guess, and that's way too much water. So that's why we need this vacuum dehydrating technique to bring this oil back to life. All right, guys, so here's the idea. That was a little bit tough to do with just one person. And it ain't perfect, but she's straight up and down, and that's what matters. To have at least enough head height here to fill into a 5-gallon bucket, because probably I'll be dumping in with a 5-gallon bucket and collecting with a 5-gallon bucket. All right, so we need a way to fill this thing. I got a Chinese 2-inch ball valve. That will be on the top. That will be our fill port. Then we can close it off so the tank holds vacuum and pressure if needed. But drilling through the thickest part of this tank I'm a little worried about. We'll see how that goes. Well, if you guys are wondering, as I was, I drilled a test hole. The bottom of this thing is almost 3/4 of an inch thick. So it's funny when the bottle shop says, oh, this thing's too pitted, we won't fill it for you. Well, I think there's enough material there to still make it happen, but I'm not positive that my trusty hole saw's got 3/4 of an inch of hard steel in her. We'll just have to take it low and slow. Getting close here. I'm putting a magnet on top of the slug, so I really don't want to lose this in there. And I don't think it's going to stick in the hole saw like it always does when you don't want it to. Oh baby, there it is. And I caught it. Oh, that could not have worked any better. Hell yeah, brother. That's what a 2-inch hole in the bottom of a welding bottle looks like. If you guys are curious, you know, I was always wondering, how much meat do these things have on them? I would say they're fairly hefty. It doesn't really feel like this wall thickness tapers off. It's not like it's just thick in the center. I feel it, you know, kind of contour out. I would say this thing, this size bottle, is pretty uniform across the bottom at that wall thickness there. Now, this is an old bottle. This is probably from the 40s or 50s, so I don't know if they make them like that anymore, but made to last. Well, that's my sign, I guess. I'm out of welding wire and the sun's up and I gotta go to work anyway, so catch you guys when I'm back. Alright, fill valve is welded on. I got the band heater on here now testing it. This is a pretty small band for the amount of mass going on here. But it does get pretty hot. I mean, it's already too hot to touch. I just plugged it in. So we'll see. It'll take probably a long time. That's okay. It doesn't quite fit, so we got a temporary zip tie solution here. Now let's get on to some instrumentation for this thing. Oh yeah, this tank's already heating up. Wow, that thing works pretty good. Alright, so I put a 45-degree flare up here. That way we can connect a standard HVAC suction hose to this. And that should interface with our vacuum pump pretty nicely. And then we got a vacuum gauge here, so we can see what's going on inside. Down here, I'm still waiting on it to arrive, but I want to put a temperature gauge down here to measure the temperature of the fluid. That way, if we know the temperature and the pressure, we'll know if we're boiling the moisture or not. Really can't see in here. Well, we kind of can. Let's do that. Put a sight glass in down here. Hopefully that'll give us an idea of what the fluid looks like, if it's clearing up or not. Also one up here. I would say this would probably be my max fill level. What my concern is that as the water boils out of the oil, it'll foam, and I don't want all that foam run into the vacuum pump. So hopefully we'll be able to get an eye on what's happening here with this one. Maybe 20 minutes with this heat band on. It actually is boiling water right now. The tank right above it is not yet, but it is evaporating fairly quickly. Remember, we only have to get this oil up to 100 degrees Fahrenheit. So this is gonna work, I think, great in the summer. In the winter, it's gonna be tough. This heat band may not do it. I may have to blow some propane at it or whatever, but we'll just have to try it and find out. So I got a couple more parts here. So we have our discard valve, I'll call it. So this would be if I'm not confident that I have clean fluid. I'll open this valve and that'll allow me to bleed some off, see the condition. This valve will be for actually draining it. Runs through a 10 micron filter and then right back into a preferably clean bucket here. All right, first vacuum pump check. Turn it on. Five inches. Really, if I have any leaks, I'll be adding air back to this to pressure test it, because it's very hard to find vacuum leaks, but pressure and a little soapy water goes a long way. And this is worst case scenario, because if we're full with fluid to here, we've only got this much airspace to pull, but we'll see how she does. See where she deadheads at. So I got a little vacuum versus pressure chart here for boiling point of water. If we can get 27 3/4 of an inch, we only need to get the oil up to 104 degrees. If we can get 29 inches, we only need 76 degrees. So the more vacuum we can get, the lower we need to get this thing hot. Now in the summertime, 76 degrees on a hot summer day, I won't even have to put the heater on. I could just throw the pump on it and let it rip, and that's the ideal case. Right now it's 32 degrees out. It's probably 50 out here in the shop, so we really do need to get a high vacuum on this. I found and fixed a couple little pinholes, air tested everything. Now we're pulling down to, it's about 28.5 inches, and it pretty quickly. We'll see if it goes any lower. I may still have a leak somewhere. 28 inches should be somewhere between 100 and 90 degrees, probably 95 degrees that would boil at. I'd really like to do even a little better than that. All right guys, this is why we're here. So I just drained 5 gallons of milkshake out of this machine. This oil's not supposed to be this color. And when you run this, it almost froths up into like a, I don't know, like a thick milkshake, literally. So unfortunately it's like 30 degrees out. This oil is very cold. I guess not cold enough to freeze because there was no ice on the drain plug. That is emulsified water in there. I don't know how much. I don't know if this is 1 quart of water, 1 gallon of water, or a couple teaspoons. I have no idea how to judge that. Seems like a lot to me. But that's what this machine is built for, so let's see what happens. There we go. Dude, that is some nasty oil. I don't like that. I don't feel good about it. The problem with the backhoe is that fluid goes out to the cylinders. It might stay out there for a long time. It's actually hard to dilute that and bring all that back to the transmission where I can drain it. You know, it'll happen over time. This is going to be one of them things where maybe twice a year I do this until the fluid's clean. I'm not going to let any new water get in, but cleaning up this years and years of mess is just no good. I think it's really tough on the hydraulic pump. I think it's tough on the seals in the cylinders. You know, it could cause rust. I don't see any rust. I think the oil does a good job of, you know, protecting against that rust, but it's not cool. All right, we're full. Well, we're not full. We got 5 gallons in. I also added a thermometer to this just so we could keep an eye on things. The heat band's been running a little bit. The tank is warm. The oil we just dumped in is ice cold, and I can feel the ice coldness down here. For some reason, the sight glass isn't full, and I think there's air trapped in this portion here, so we're not going to get to use the full sight glass potentially until that air comes out of there. But evacuating it will be a nice test to see that pull down. Temperature right now of the fluid is apparently 78 degrees, which is very warm. I don't believe that yet. I don't think that's the full. I mean, the tank is hot. This thing was running at 140 degrees before I put fluid in, but I do feel it cooling down, so it's going to take some time. But let's get the vacuum pump fired up. Be interesting to see if we pull this air out of here and this fills with fluid. That will show us that it's working, so that's interesting. Nothing here. I do suspect I could fit a full 10 gallons in this column. Nothing to do now but to try it. All right, it's a 10-minute update here. I moved the heating band to the bottom because it was stupid being up here because the heat was just rising up. So now we'll at least get closer to the bottom of the fluid. It says we're at 72, which is pretty good because the fluid was very cold. Vacuum wise, we are hanging out just above 28 inches. you guys can see the vapor coming off of there, but there is vapor coming out of this. Whether that's entrained air that was in the oil or it's actually moisture boiling off, I don't know yet. Based on the temperature pressure chart, it shouldn't be moisture yet, but we just gotta see. Well guys, it's working, and it's working great. So the oil is now 116 degrees or so. Vacuum has actually dropped a little, and that's because we're starting to boil. I can hear it. I hear a pretty aggressive boil in there, but anyway, she is boiling. Now the issue is we have clouded up the vacuum pump oil pretty badly, and the level has increased substantially. So I'm gonna kill the vacuum. It's gonna continue to boil in here until that pressure equalizes, and then we're gonna change this oil real quick, see what we get. See how cloudy that oil is? A lot of this moisture is gonna end up in the pump oil. Unless I build some kind of trap to separate that, I don't know there's much we're gonna be able to do about that. But the oil's cheap enough. We'll change it out every, I don't know, we'll see what it takes. I mean, I don't know. I don't know how close we are. By the vigorousness of the boil that I hear inside the tank, I would say we're not even close to getting this moisture out yet. How much have we removed? I have no clue. We got some condensation here, which is good. And then condensation here as well, but if you look at the quality of the oil, now it looks much more clear. That was milkshake there when we first started this. Alright, that's our first filtered sample. Shoot. Much darker than I was expecting it to be, because it was so light before, but I was never able to tell if this fluid was dark or not because it always turns into a milkshake. I don't know, what do we think about it? Oh, no change with agitation, so that's good. Not super happy with how dark it is though. That's what I wasn't expecting it to be so dark. And it could just be dirty. I mean, I put probably 20 to 25 gallons of fresh fluid in this machine. They say it only holds like 30. But does the boiling process make it darker? Potentially. Does it have very small particulate in it? Potentially. This is a 10 micron filter. Probably does most of the work, but I don't know how tight the filters are on the machine. But when you dip a towel, it doesn't turn black. Like this isn't black. It's very clear when you when you look at it like that. And honestly, I've never looked in the top of a new drum or a new bucket of this VP Tractor Supply El Cheapo oil. It might just be fairly dark. So this here makes me feel a little better about it. Clean bucket. Clean-ish oil. So as a comparison here, you can really see the difference. So you can't really compare these levels exactly because I took like 2 quarts as, bleeding and sampling and that kind of stuff. And, I don't know exactly how high these buckets were filled to say how much water we actually removed, but this looks like hydraulic oil, though it's black. This is that milkshake crap that I don't want to see in my machines anymore. Just grabbed another fresh bucket of shmoo as well. So we'll do 10 this time. It's possible that some of this is entrained air. That's a whole separate issue. It's possible there's a high pressure leak on this machine somewhere and it's aerating or cavitating the oil. Or it's just water, I don't know. we'll just have to keep drying it out and see what happens. So something interesting I noticed is I have oil down here under the thermometer. And unless I miraculously spilled it somehow and never touched this, I think it's actually leaking from this fitting. And this was added after I leak checked everything, and it's possible this weld leaks. I can tell you the weld leaks, I see it right now. So a lot of that air we heard bubbling, which we assumed was boiling, may have actually been coming from here. So that's something to know. But anyway, got 10 gallons in here. We hit the top sight glass. Let's give her a full run. So I just threw another bead on this, got that to seal up. Then when I started running it, either because it was getting air bubbles, it splashed oil into the line, so I had to drain the pump again and put fresh oil in that. So I took about a gallon out just to be safe. So there's only 9 gallons in here. That's kind of disappointing because 10 is a nice even number when you're working with these buckets. But anyway, I think this thing's still got a very small leak, but it's really, really small. I just hear a little so nothing to worry about. This time we're gonna time it, so it's 6:12 p.m. I would expect by 10 p.m. this fluid's ready to go, but we'll see. 10:12. Just came back to check on this thing. 125 degrees, about 29 inches. She's nice and warm. I don't hear anything. I think this is boiled out. Let's check it. Looks pretty good to me. Man, that looks nice. So that's like 8 gallons in 4 hours. I'm just working on other things, chilling. I really didn't check in on this thing. Maybe it's done in 2 hours. I don't really know how long it takes, but that is phenomenal. Beautiful. The oil looks dark, and honestly, I've never taken the lid off a hydraulic bucket when it's still full, but I mean, look how good that looks. You touch it on a paper towel, it's almost got no color. So it looks very dark and dirty down here in the bucket, but this is actually very clean fluid to come out of a machine in this condition. Well, it's the next morning, threw a couple more gallons in, or up to 140 something degrees. 29 inches, so you know there's no moisture in there. Pump oil is a milkshake again, meaning we have been pulling moisture. I won't bleed our vacuum off. Looking good, boys. Looking good. So this would be 15 total gallons so far. Probably got another 60 to go. Who knows? 5 more gallons done. Gorgeous. Gonna go ahead and wrap this one up here. For the weekend, I dehydrated 25 gallons of hydraulic oil through this little contraption here, and it really does work well. Right now, it does take 3 to 4 hours to get a moderate amount of moisture out of a 5-gallon batch. In the summertime, with a bigger vacuum pump, I think you could cut that down to like an hour and a half pretty easily. I was dumping in ice cold oil with a cold cylinder and a tiny vacuum pump, and it's still getting the job done. So the physics don't lie. Low heat, high vacuum, no need to overheat the oil. The water comes right out of it. Really works awesome. Plus the added benefit of, running it through a filter, letting solids and other heavier parts settle out in the process. It's kind of nice to recondition your oil a little bit. Now, there's no replacement for new oil. I don't think this is something you should build and then run 30-year-old oil through that's just been used up. It's not really for reconditioning like that. It's just for stripping moisture. And in the case of two machines that I have, you know, combined, two machines hold 50 gallons of hydraulic fluid and they have moisture in them, and you can't just replace that 50 gallons and it goes away. You have to continually cycle that through to get that out of there. So this has already paid for itself on its first job. The backhoe oil is starting to look a lot better already with 25 gallons through it. I think once I run 50 through it, she's going to be mint or good enough for what I'm doing. And then we'll take this down to the mountains and we'll do the same process with the dozer. There are a couple other options for this. They make like coalescing filters which capture water molecules and strip them from oil. I've never tried them. I wasn't that interested in it when I saw the cost versus how much oil and water I can actually use. This is kind of a one-time buy. As long as you keep the vacuum pump running, this will last the rest of my life. Maybe I'll have to replace the heating band a few times, but this tank's already 3 times as old as I am, and it just started its second job. So this thing's gonna be around forever. There's nothing really fragile on it. They're all cheap instruments from Amazon. So if I roll this thing out in the driveway and it flips over and I break the gauge off, it's $7 and we're back in business again. So anyway, guys, this is a fun little one. It was nice to dream it up in my head, come out here and build it for minimum cost, and then actually see it work. I can't be more happy. Like anything with waste oil and reusing oil, it is a messy process. You're gonna splash it, you're gonna spill it, you're gonna smell it, you're gonna get it on you. It is what it is. I heat my shop with waste oil, which is it's a process you just got to get over. If you want to do stuff on the cheap, do stuff on the cheap. If not, head to your local dealer, spend $200 for 5 gallons of hydraulic fluid, and continue doing that until your fluid's clean. Anyway, as always, thank you for watching Spank Ranch Garage. Let me know what you think about this down in the comments. I'll see you next time.